Okay, so this is the idea. ISP is going to provide the meaning to the community tags. ISP will simply provide you the tag. We use the tag and we advertise. ISP will see the tag. In our case, Autonomous System 20 is our ISP, and we are Autonomous System 10. ISP will see the tag, and accordingly, ISP will provide the service. What is the service? ISP should forward the traffic from the internet to 13.13.13.13 out via router 2. If it is 12.12.12.12, the traffic should come via router 3. In case if the link between router 1 and 3 fails, both the traffic should come via router 2. If router 2 and router 1 between link fails, 13 also should come via router 3. Did you understand? Did you understand? This is what we are going to accomplish using community. All right, so according to ISP, let's say 10:400 means high preferred. 10:200 is low preferred, less preferred. So now you see in both the routers, the policy will be same. ISP will not have different policy in different router. For each router, if they start writing policy for every customer, they cannot do this. It's not scalable. Both the router has got one policy. What is that? If a traffic has got tag of 10:400, that will have high weightage. So this is the idea. Because this router 2 has got high weightage tag 10:400, I'll say 13, 13, 13, 13 with that tag. When I advertise from router 1, 13, 13, I'll put that tag which is highly preferred here. Whereas when I advertise 12, 12, 12, 12, I'll advertise with this tag so that router 3 will prefer. And for the backup, in case if the link goes between router 2 and router 1, it has to fall on router 3. So I give this and like vice versa, reciprocal. You see? Here for 1313, I want to give more weightage, so I have tag of 10:400 advertised from R1. Whereas from R1, when I advertise to router 3, for 12, 12, 12, 12, I advertise with the tag of 10:400. Now let us use local preference to do this. So on router 2 and router 3, we have one common local preference. What is that? If 10:400 matches, local preference is 400, which means for 13, 13, 13, this will say 400. Whereas this one will say 400 for 12, 12, 12, 12. Does that make sense? In our example here, for all the traffic that needs to leave router 2, tag is 1 0:400. This is the tag that will be given to all customers, whichever expects traffic to come out from router 2. Traffic that should come out via router 3 will be given 10:400. Now, I'm going to use a notepad to do the basic configuration along with the basic BGP. So notepad here, enable config T, interface loopback 0, 12, 12, 12, 12. Interface F00, 10, 12, 12. Interface F01, router BGP 10, neighbor remote AS 20, neighbor network. Done. So router 1's configuration is over. Verify before we move. Show IPBGP summary. 2 neighbors are configured. Show IPBGP. 2 networks are getting advertised. Show IP interface brief. Those 2 loopbacks and 2 physical interfaces are up. Now, let's move on to router 2 configuration. Router 2, I don't want any loopbacks. On router 2, no loopbacks. F00 will have 2 here. F01 will have, oh no, I made a mistake. Here I want it to be 100 on router 1. So let me paste. Put wrong IP address. Show IP interface brief now. It should be 100. Okay, now it's correct. Now let's move on to router 2 configuration. Router 2 F01 is 1023. To router BGP. Router BGP 20. Neighbor is 10, 12, 12, 1. Remote AS is 10. Neighbor is 10, 23, 23, 3. Same remote AS. And then neighbor 10, 23, 23, 3. Next hop. Self. And then No network to advertise. The community part later. Router 2 is done. Expecting one BGP neighbor. It's not one, it should be 2. Okay, now I'm expecting one neighbor. Neighbor has come. Also, I'm expecting networks show IP BGP. It will come. Show IP BGP summary. Neighbor has come. This should be removed. No, this is not. Here I'm expecting 2 neighbors. Sorry, 2 networks. Show IP BGP. Why this is not having best? It should be best. Show run section router. Mask is correctly configured. Will take time. Now if you go to router 2, you should get 2 prefixes, and here it is. Okay. Now moving on to router 3's configuration. Router 3 F00 is 1313. And F01 is 2323. We also have a serial interface serial 3/0. And between this, I would like to have 200. 200.34.34.3 0. And the neighbors are 13, 13, 1 and 23, 23, 2 and neighbor 200, 34, 34, 4. Remote AS 30. That's it. This will go on router 3. Now I'm expecting 2 neighbor, 1 eBGP, 1 IBGP. Yeah, show IP BGP. All right. We are learning. Now eBGP will be preferred over IBGP, so it will go out via straight to router 1. This will become greater than symbol here shortly. BGP is a bit slow, it will come. Right. So this is exiting via eBGP, straight to eBGP. This is also exiting via straight to eBGP. Okay. eBGP is preferred over eBGP because there's a tie in all other attribute. Now, next is, let's finish router 4 and then we'll start community. Router 4 has got one loopback. Loopback 0 with and here serial 4/0 and this is 4. BGP is 30, 3 and 20. All right. So this is going to router 4. Now I'm expecting a neighbor. Where's the neighbor? Show IPBGP. Oh, it has come. No. What happened? Ping. Oh, the neighbor is not 2. Sorry, it's a wrong address. It is 2, 3. 2 I should put no. And it is 3. Now the neighbor has come. Show IPBGP summary. Neighbor has come. 2 prefix learned. Show IPBGP. These are the prefixes. And soon it will become best. Hmm. Okay. Now if you try to ping 12, 12, 12, 12 with a source 444, you will be pinging. And when you trace the same, it may go via router 3 to router 1. Yes. We are okay with that. Are we okay with this? What is our aim? Our aim is 13 should come via this way, 12 should come via this way. Okay. That is our aim. 13 should come this path and 12 should come this path. So this is okay for us if it is 12. But for 13, we are not okay. But 13 also, it will go via this way only. You see, 13 also, it goes via the same path, which is not the one we want. So we are going to use the community to achieve this. ISP has given two tags. First of all, customer should tag and send. Let's do that one now. I'm going to write access list 12 permit host 12 12 12 access list 13 permit host 13 13. Now I'm going to write two route maps. Route map to router 2 match 12 match IP address 12. If that match happens, set community 10:400. And I put another sequence number and I don't do anything. Or I can say set, for the rest, set community 10:200 for the other. Means rest means it is going to be 12 12. Those are the two things we have. Now done. Next is I need to attach this. Router BGP 10, neighbor 10 12 12 to 100 100 100 100 12 12 to use the route map to R2 out. Done. Likewise, I'm going to write another route map to R3 match IP address what did I say in the previous one? அது ஏன் சார் முடிஞ்ச பின்னாடி சொல்றீங்க? நான் கண்டுபிடிச்ச பின்னாடி. சரி. I'll do one thing. I'll remove the route map. Route map to router 2. No. Or before that, do show run section route map. Okay, so I'm going to say no route map this, and I put this. For route map 2 router 3 only, we have to send this one. Oh no, again I made a mistake. Okay, let's do fresh. No confusion. Another thing is when I type show, you saw the big number, it was not showing the new format. So how do you get the new format? BGP IP BGP community new format. Oh, that's it. Now let's do again route map to 2 or 3. Cancel. I created this earlier. 2 R2 also I cancel. Now I'm doing fresh. I'm saying match IP address 13. If this 13 matches, set community 10:400. With sequence 20, match IP address 12, set community 10:200. And we need to do the opposite. So show run section BGP section route map. I will copy and use the notepad to do the opposite. I use the notepad and I put 3 here, and for this I'll put 200, 3 here. So this means 12 means 400. This is what we want. 13 means 200, 12 means 400. That's perfect. Copy and put it here. After doing that, let's verify. Show route map. If you see here, if 13 matches 400, whereas here 13 matches 200. Perfect. Now let's go apply this to the neighbor. Router BGP 10 neighbor 100.13.13.3. Use the route map 2 R3 out. And now one more thing I have to say is send the community. Neighbor 100.12.12.2 send the community. Neighbor 100.3 send the community. Now, if I go to router 2, I should see the community. Show IP BGP 12.12.12. You don't see any community here, which means we have to refresh. Clear IP BGP start soft. You see, for 12.12.12, the community is this. And on router 3, for 13, the same should be the community. Show IP BGP 13, 13, 13, 13. I should see the same number 65550. Correct. So to get the new format, you say router BGP, IP BGP community new format. Here also IPBGP community new format. Now it will be more clear when you say show BGP 12.12.12.12. You get the community 200 only because 13 is what preferred here. You put 13, you will see 400. 400. Whereas for this one, show IPBGP 13.13, you will get only 200. You get 200, whereas for 12, you will get 400. 400. So now when it finds 400, it has to give high local preference on both the routers, same policy. First of all, we need to write a community list. On router 2, I'm going to write a community list. IP community list 1. Permit. What to permit? 10:400. And also 10 colon community list 2 10:200. Okay, we have two community lists. Do the same on router 3. So on router 3, I put the other line also. So next is we need to use the route map. Route map. Give any name. I'm going to say policy outbound. Match community list 1. If that happens, set local preference 400. All out 20. Match community list 2. If that happens, set local preference 200. All right. Now for the rest, we don't have any other network. For the rest, simply you can create 30. It's optional. In our case, it's not needed. Okay. And now I need to, first let me do one thing. Show run a section. I want to copy these things because it's the same thing all the routers should have. In ISP, they won't have different policy. It's not easy for them to maintain for each customer different policy on every route. So I copied for another router, no change there. Here, only the neighbor change. Router BGP 20, neighbor 100.12.12.1. When he gives user route map, policy out, and that update is coming in. As the update comes in, this should be the outbound policy for those destinations. That is all here. Clear IPBGP soft. Now let's go to router 3 side and paste this. Right now, if you see, the traffic will go via router 2. All traffic will go via router 2. You can see it now here. Show IPBGP. You see, both 12 and 13 is going via router 2 because of the local preference 200 and 400. My community is working fine here. All right. Now, router 3 configuration, router BGP 20, neighbor, use the route map, poll out, as the update comes in. Okay, clear IPBGP star soft. That is all. Now you will see what we spoke as the policy in the beginning. Show IP BGP. Here, if you see for 13, it says I will go via router 2. That is what we were expecting. 13 should go out via router 2. And whereas for 12, it goes straight out via router 3 itself. Likewise, on router 2, show IP BGP, it says for 12, I will go via router 3. Whereas for 13, I myself will be the exit. That's right. Right. So now let's trace route and see. For 13, it should go via the other path. You see, it goes via router 2. Whereas for 12, it should go straight. It is going straight. Right. We have achieved this through BGP community. Any question?